Okay, let's look at the Boyles law problems. So I gave you two problems to practice with Boyles law. I distilled what the question said into what P1, V1, P2, V2 were. That's how I always like to start problems. And in here, looking at this with Boyles law, with all the gas laws we're doing today, consistency is what matters with pressure and volume units. So here with pressure 1 and pressure 2, they have different units. So I would want to convert them so they're the same thing. I could convert them both to something different, but it makes more sense to either convert kPa to ATM or ATM to kPa. Okay, so I'm just going to convert my ATM to kPa because it's first and that's what I wanted to do. It really doesn't matter. So I'm going to use those pressure conversions that we did before. I'm plugging this in my calculator and I get out that this is going to be, rounding to sig figs, 9.59 kPa. Okay, so now I have two kPas and I have my volume in milliliters. I don't have to change it to liters, but my answer in the end will be in milliliters. So now I'm going to put this in the equation. So I'm going to do P1 times V1 equals P2 times V2. And then it's just solving for x. So in my calculator, I'm going to multiply those two numbers and then divide by P1. So I'm going to do 9.59 times 150 divided by 98.7. I'm going to round to the least number of sig figs that were given. All of the sig figs that were given were 3 sig figs, so that's what I'm going to round to. And so looking at this, it was 14.57. So I'm going to say the x is 14.6 milliliters. Okay, so let's look at the second problem. Second problem, we're looking for P2. We have our two volumes. But looking at our volumes, this volume is in liters and this is in milliliters. So again, they need to be the same. So you convert either liters to milliliters or milliliters to liters. It doesn't matter. Let's convert our liters to milliliters. So I'm going to times it by 1,000. So it's going to be 1930 milliliters. I'm going to plug this into Boyles law. So I'm going to take my 126 kPa times 1930 liters equals x times 740 milliliters. And then again, I'm going to times these, divide by that. So once I put it in my calculator, I'm going to have 126 times 1930 divided by 740. And I'm going to get out, it gave it to me as a fraction. My calculator likes to do that. It gave it to me as this answer. I'm going to round to 3 sig figs because the numbers I was given were all 3 sig figs. So this is going to be 329 kPa. And it's just kPa because that's the pressure unit I started with.